All right, so I already did this lesson once the whole way through and didn't have any audio on it. So let's take another crack at it this time. I might post both of them, just maybe you prefer the one that where I don't talk. So it's Algebra 2, Lesson 2-6, the quadratic formula. Hopefully, maybe you've seen this before. If not, it's up here in the corner in the white writing. I know some teachers teach it to a little song that goes something like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Pop goes the weasel. So, if you want to learn it to that, a lot of places in higher level, they will expect you to have that memorized. So if you don't already, sometimes I tease kids and say, come on, there's a YouTube video of a little girl named Emily that has it memorized. She's about maybe 3 years old, something like that. I always say, come on, if little Emily can memorize it, you can. Anyway, so using the quadratic formula to solve these quadratic equations, you get your a from the coefficient of the x squared term, your b from the coefficient of the x, and your c is the constant term, or x to the 0, if you will. And you just plug them into that formula in their corresponding spots. Sometimes you're going to get an imaginary or complex number, so we'll take a look at one of these examples that's going to do that. So x equals negative b, b being the 7 would be a negative 7, plus or minus the square root. And if you want to work some of this out as you go, like this is going to be b squared, the b squared in the formula, so that's 7 squared, 49, minus 4 times a would be 16 times this negative 11, all over, and this is solving for the x equals 2a, a being the 4, so that's going to be 2 times 4, or 8. Now, there is a little, so I've got 11 times 16 here. I'll show you this little trick somebody showed me once upon a time, that if you want to do 11 times any number, in this case 16, you're going to get the answer by, you bring the 1 down, you bring the 6 down, and then in the middle you add these together, so it's 176. So I've got 49, it'll be a negative times a negative, so it's going to be plus 176, all under that square root. A little later we're going to call that number under the square root the discriminant, so I'll throw that name in while I'm here, so you get another chance to be exposed to it. Under the square root of the, that's gonna, at some point here, absolutely grab a calculator to get your answers. So my 49 plus my 176, in this case 225. And then I happen to remember the square root of 225, use your calculator if you want to, is 15, all over 8. So that you have to get two answers here, one where you're adding the 15, one where you're subtracting. Obviously the subtracting would be smaller. So let's see, I'll just branch these out. Negative 7 minus 15 would be negative 22 over the 8, and negative 7 plus 15 would be 8 over the 8. And so you're going to get, that one's easy, 1. And then this one, if you simplify that, 2 divides into a 22 11 times. 2 divides into 8 4 times. So that's like a negative 1, no, negative 2 3/4, maybe, if I'm doing that in my head right. But whatever form you leave that in, but there's your two solutions. Let's take a look at the second one. So x equals negative b right there, plus or minus the square root. B squared would be 25. Minus 4 times 2 is 8. Times another 8 would be 64. All over 2a. 2 times 2 is 4. So however much of that you want to do at one time, if you write it all out and do it one step at a time, that's perfectly fine. If you use a calculator and you're really careful about how you plug it in, that's all right too. So look what happened under the square root. Under that square root, I've got 25 minus your 64 so that you end up with like a negative 39. And so that's going to be our imaginary number thing. So when you're doing that, if you need this step, since it's new, I'll write it out. When you're used to these, I wouldn't do that anymore. So negative 1 times 39 is your negative 39, and negative 5 plus or minus square root of the negative 1, that's your imaginary number I. And then your 39, I don't think that simplifies at all. So that would reduce to there. Now, a lot of times they'll want you to write it or to identify the A and the B in A plus BI. So just normally how you get a common denominator to put things together. Let's see what happens here when you can also take it apart. So I've got negative 5/4, and then the plus or minus. And I'm going to write this I times the square root of 39 over 4 this way because the I up here is separate. So just the numerical part is your B, so that would be a square root of 39 over your 4. So the weird thing, and it kind of takes some getting a little used to, this B in this case is just this part here. But we do still have two answers again. We have the positive square root of 39 over 4I and the negative to get two different answers. So that's using the quadratic formula for a real solution problem, and then the second one, imaginary or complex. And sometimes we're going to call those complex or imaginary roots. That's when this comes in, especially the roots word, because it's not actually a zero. The zero implies where you cross the x-axis. So if you had these, they'd be like zeros. This is going to be, we're going to see this in one of the next examples anyway, but so you wouldn't have any x-intercepts for this imaginary one. And let's just hold off there till we get to that anyway. So the next problem, so which method should you use to solve it? Well, if your factoring skills are pretty good, and you can factor, especially say on one like this left problem, x squared minus 7x plus 12 equals 0. If you can somewhat quickly realize that 3 times 4 is this 12, and if you add them together, you can get this negative 7. Negative 3 times negative 4 is a positive, but they would add up to the negative. So then it goes much faster when you can identify that. So x times x, my x squared, there's my negative 3x, there's a negative 4x, combine those to make the negative 7x, and negative 3 times negative 4 does equal to 12. Set each factor equal to 0. Undo your operations to get x alone, however you want to show your work for that. And get your two solutions that x is either 3 or x on this one would be 4. Well, the next one, when you've got this 3, you've got this 12 that's got a whole bunch of factors. Sometimes this 3 might be a 6 or whatever that has 24 or some number that has a lot more factors to it. Becomes a lot more challenging to try to find if it even factors. So on this one, that's where I would resort to doing probably quadratic formula, using a graph and calculator, looking for x-intercepts, some other method. But so x equals, so here's my a 3, here's my b 7, here's my c, the negative 12. X equals negative b plus or minus the square root b squared minus times this minus on 4ac is going to be a plus. 4 times 3 is 12, times 12 is 144. However much of that you can do in your head at one time. If you don't want to do that much, that's okay. Do it step by step. And 2a would be my 6. So negative 7 plus or minus the square root of, that looks like about 193 under there, all over the 6. And if you want to get, sometimes in science classes especially, or real life, sometimes I do not understand. In math, we like you to have your answer in an exact form, but other places they want a decimal approximation. So if you do that, then split it up. I would remind you that the minus part will be the smaller one. You don't have to do that first, but for me, smaller numbers on the left, so I'm just working it on the left side. larger numbers on the right. So I'm just going to work that one on the right side. And just come up with a couple of decimal approximations so that you understand that in some places they do like you to do that. So I'm just plugging it into a calculator, -7 minus the square root of 193, hit enter, got about a negative 20.89, divide that by my 6 and get an approximation of about negative 3.482. I kind of like to round it off with a few extra decimals when you're entering them in the calculator, or I mean in the computer especially. It seems like the more accurate you go with your decimals, more likely it's going to count it correct. I don't think, I've had students tell me they think they entered it with too many decimals and it counted it wrong, but I don't believe I've ever actually seen that happen with one that I'm doing. So the more accuracy, the better. Second one, -7 plus the square root of 193, around 6.892-ish, and divide that by your 6. So your bigger answer, in this case, the 1.149. So those two would be my solutions to that problem. Notice I did use this squiggly equal sign. So x, if it were either one of these two numbers, would work in that original quadratic, approximately, because I've rounded them off. All right, then we have this thing. The part that's under the square root in the quadratic formula is called this vocab word, the discriminant. What they're going to do with this is they're going to use it to determine, well, if what's under the square root is negative, we've got a square root of a negative, so we're going to have those imaginary or complex roots or complex zeros. There won't be, when we graph those, there won't be one for that where they cross the x-intercept. So we're basically going to end up with three possibilities on our graph here, and that's kind of what we're after on this example, seeing what causes the three examples, or the three different possibilities on the graph. So the first one, again, I'm looking at that, the 5, the 10, the 7, I could do something quickly if I wanted to try to see if I could solve to factor. I don't know, it seems like it's possible. I don't see the answer that's going to jump out at me. So I am going to just jump into the quadratic formula. X equals negative b. There's your b. A, b. Don't forget c is a negative 10. Plus or minus the square root of b squared, which should be 49 minus 4 times 5 is 20 times 10 is 200, and it was a negative times this negative would be a plus all over 2a. So this one, if you graph this, you could find out from your graph what those two decimals are here. I'm just going to do them on the calculator quick. -7. Again, I like to do the smaller one, the minus first. And then the larger one with the plus second. And those are going to be my x-intercepts. And so if I do that, -7 minus the square root of 249, get that answer. Divide it by the 10, and I got around a -2.3-ish, so, you know, over here. Squiggly equal sign again to admit that I rounded it off. So if I needed to at a later date come back to a problem and be more exact, that I can. And then do the same problem, but change, instead of that minus in front of the square root, a plus, and divided by 10 on that one, and I've got about a 0.8. So that one's going to be closer to the x-axis. Actually, 0.9 would be a little more accurate. I've got a 0.877. So it's a parabola opening up because of this positive 5. I've got a y-intercept of -10 down there somewhere. So it's going to be going something, a rough sketch, something like that. Again, this point down here on the y-axis will be the -10. X is 0, so when you put a 0 in here, 0 squared 0 times 5 would be 0. 7 times 0 is 0. The only thing left when you put in an x of 0 on for your y-intercept. Second one, I'm not even going to do anything with a quadratic formula or anything else, because I remember that this is a parabola that's been shifted 2 to the right. So you can go through the other parts if you want to, or set your factors equal to 0. You're going to get just 1, 2x2, positive 2 for an x-intercept. So when you get one like this, originally this would have been x squared minus 4x plus 4 if it were in standard form. This is technically in factored form because it would be x minus 2 times x minus 2. Set either of those factors equal to 0 and undo, and you're going to get a 2 for your x-intercept. Your 0, where y is 0, where it crosses the x-axis, or again, the root. And I think we'll see why the root again on this last one. Again, I'm not seeing the factoring, and you can try the factoring by grouping method if you want, and I think you'll see that doesn't work either. So jump straight to the quadratic formula here. Let's see what happens. X equals negative b plus or minus the square root of 2 squared, which is 4, minus 4a. 4a would be 4 times 3, 12 times 10. 12 times 10, 120, all over 2a. 2 times 3 is 6. So look what happened here. Under that square root, that's a negative 116. So this is going to be an imaginary solution. Now we do know, again, from the original problem, that it had a y-intercept of 10. We know it's opening up. If we wanted to find that vertex, remember we did this too? Negative b for the vertex. Negative b would be negative 2 over 2a. 2 times 3 is 6. So I know my x is negative 1/3 on the vertex, so if we call that a negative 1/3. And then do you remember, you substitute that in to the original problem here to end up finding, we're going to put the negative 1/3 to find this is like our y over here that goes with it. So if I put in 3, I'm going to put in parentheses the negative 1/3. I'll put negative 1 divided by 3 squared. Then plus 2, and in parentheses a negative 1/3, negative 1 divided by 3 in parentheses, and then a plus 10, and I got an answer that says I made a mistake and got an error. Whoops, what did I do? 3, must not like using all those parentheses and stuff that I did. So I'm on the TI-84 to get a fraction in there instead. I can do 3, and in parentheses alpha y equals, select the fraction and just put it in. So it actually looks like a fraction, negative in front of the fraction, or negative 1 on top, and 3 on the bottom. Square it, close my parentheses before the squared, plus 2 alpha y equals, use a fraction, times my x again of 1/3, negative 1/3, right? And then let's see, plus my 10 outside of the fraction, arrow over, and I see 29/3. 3 goes into 29. So that's like 3 times 9 is 27. 28, 29, 2 more left. So like up at 9 and 2/3. So that's actually pretty close here to that 10. So, but I do not have any x-intercepts for that problem. So I think we've got one more example, and that is a word problem. A lot of times they'll give you with these. So I've got this equation that tells me at any time t in seconds, this is the height of a ball. So whatever the ball is, it could be a volleyball, it could be a baseball, it could be a golf ball, whatever, but it is being hit into the air and coming down. You have this negative 16. I think that's the coefficient to gravity that's in there. So You've got some other science involved here, but the two questions a lot of times that are asked, what's the maximum height of the ball and what time does it happen? And the second one, like you see over here, is when does the ball hit the ground? So think about it in a graph. Again, I'm starting on my y-intercept at 3. That's sort of like at time 0, whoever's hitting it or throwing it or whatever, that's how high the ball is. It's opening down, so it's going to be going up and then back down. And right here, when the height hits 0 again, that's the height of the ball when it hits the ground. So now how do we end up finding the two things? Well, here's my max height. Again, the axis of symmetry, line of symmetry, which again is on the vertex. It's just this x part of it because all the x's are the same on that green dotted line there. So negative b in our problem would be negative 55 over 2a. 2a, the negative 16 times 2, negative 32. And then how do we find the maximum height? That's the time. So this is t seconds. So this time right here where we hit the maximum height would be 55 over 32 exactly. Or again, I know in science they like you a lot of times to have that in something that has a little more meaning to it. So 55 over 32, like 1.7 seconds. And then for the maximum height, well, how do we find the y that goes with that? Same as the last one, plug it in. So I'm going to plug in, I'm going to use the 55 30 seconds so that I keep my answer as exact as possible. Negative 16 in parentheses. Again, on my calculator, alpha y equals gives me a fraction. The 55 over the 32. Close my parenthesis on my fraction and square the fraction. And then add my 55 times my alpha y equals and the 55 over 32 there. Again, close the parenthesis on the fraction, add my 3, and I come up with like a fraction answer here of 3217 all over 64. Again, on my graphing calculator, if I hit the math button and the second thing down says convert it to a decimal, because I don't know what that fraction really represents, and it says 50.265. So both of these are approximations. Don't forget to include that. 50.265. And I think that the problem say the height, it didn't say what it was measured in. Let's go up here and just say it was feet so that we label our answer to match. All right, then when does it hit the ground? So to find where it hits the ground over here, for that, that's a 0 or an x-intercept or a root. Remember what you use for that, either factor or quadratic formula. So let's go plug it in. I don't, because those numbers look kind of gross up there. I don't know that I'm going to think of a factoring method. So x equals negative b plus or minus the square root. I can't do 55 squared, so I'll write it down. 4, I'll do 4 times 3, I can do that. That's 12. And the c is the 16, and notice the a was negative, so it's going to multiply that to be a plus all over 2a. 2 times negative 16 is negative 32. All right, so now on this one, we got to find our two x-intercepts. So we'll do the negative 55 minus the square root of all that. Let's just figure out what that number is once the 55, this is, remember this is the discriminant. Our discriminant here is going to be positive, so we have two x-intercepts. From our graph, that makes sense. We have one here, we have one over here. The smaller one doesn't have any meaning in our problem because it's a negative time, and our ball started at time 0. So the negative answer will actually not be used in this case. So a 55 squared plus 12 times 16, and my calculator is giving me a 3217 there. Now in this problem, I was thinking the first time I did this when I didn't have the volume on, that the minus would give me the smaller answer, but in this case, because the minus is going to be negative divided by a negative, it's actually going to be the larger answer in this situation. So let's just check it out. Negative 55 minus my square root of 32, sorry, that was 3217, that looks like a 7. 3217. Square root of 3217, hit enter, get that answer, and divide it by a negative 32. And I'm coming up with a 3.49 approximately, because there's a lot more decimals. So 3.5 seconds is when the ball hits the ground. And that gives you kind of an overview of quadratic formula. One problem that's an application problem. Lots more that are available on YouTube that I've linked to your Canvas in the modules that you can find. And hopefully that gives you a little bit of idea of what's going on in 2-6, the quadratic formula.